When we do problems involving half-life, we're going to use this basic formula. So we're going to say y equals the initial amount times 1/2 to the power of the, and I'm going to call it the after number, over the half-life. So that after number over the half-life is in the exponent. And if we read the problem, this will make more sense. The half-life of a radioactive substance is the time it takes for half of the material to decay. Phosphorus-32 is used to study a plant's use of fertilizer. It has a half-life of 14.3 days. Write the exponential decay function for a 50 milligram sample. Find the amount of phosphorus-32 remaining after 84 days. So one thing you want to be careful of when you're doing half-life problems is that the element that they're telling you about, the phosphorus-32, you're not using 32 at all in the problem. 32 has no bearing. It's just the name of this element that we're looking at. So we're going to plug these values in. So the initial amount is a 50 milligram sample. So 50 is our initial amount. And then we have 1/2. So that's always going to be 1/2 there. And then where it says after number, that just means at the end it'll say how much is remaining after a certain amount of time. So 84 is going to be the numerator, and then the half-life they tell us is 14.3. So that's going to be our denominator. And then you're just going to plug this into the calculator. So when we go to plug that into the calculator, you can do it all at once. So you would put 50, and then for half, just use 0.5. And then to the power of, and it's 84 divided by 14.3. Close parentheses. And then hit enter. Okay, and it's going to give us 0.8524. So we're going to just round that, and we're going to say that y equals 0.85 milligrams. So if we look at this problem, the half-life of radium-226, so again, don't use 226 anywhere in your problem, is 1590 years. If a sample contains 100 milligrams, how many milligrams will remain after 2,500 years? So we're going to set it up. So y equals, the initial amount is 100. Then we have 1/2. And then the after number, so that's 2,500 on the top. And then the half-life is 1590. So just plug that right into your calculator, and that's going to give us 33.63 milligrams. And this problem again, archaeologists use carbon-14, which has a half-life of 5,730 years, to determine the age of artifacts in carbon dating. Write the exponential decay function for a 24 milligram sample. How much carbon-14 remains after 30 millennia. Okay, so this one's only tricky because they're talking about years and millennia, so we just have to convert millennia to years. So since 30 millennia, 1 millennia is 1,000 years, then 30 millennia is going to be equal to 30,000 years. So when we plug this in, y equals, the initial amount is 24 milligrams times 1/2. And then the after number is going to be 30,000, since we changed it to years, over the half-life, which is 5730. Plug that into the calculator, and we get 0.60 milligrams.